Have you ever wondered how some people seem to have total access to messaging threads across WhatsApp, Signal, and Telegram using nothing but a single phone number? It sounds like something out of a high-level cyber espionage movie, but today, we are pulling back the curtain on the exact methodology used to achieve what many call the ghost clone. Most people think you need physical access to a device or a complex QR code scan, but the reality of network-level synchronization is far more intense than that. Before we dive into these powerful protocols and the logic behind remote mirroring, we must state that this video is for educational purposes only. We do not advise anyone to use the information in this video to infiltrate someone's privacy or violate any terms of service. This is strictly to understand the vulnerabilities of the apps we use every day. If you need more resources and help, make sure you check the pinned comment or the video description for all the details you'll need to move forward. Now, before we break down the first step of the number-based synchronization process, I want to see who we have in the building today. Drop a comment right now and let me know which messaging app do you trust the most for your private data: WhatsApp, Signal, or Telegram? Tell me why in the comments. Also, if you want to stay ahead of the curve on digital security and system fixes, hit that subscribe button, tap the notification bell, and share this video with someone who thinks their phone is unhackable. The first thing you have to understand about cloning via phone number is the concept of virtual signal interception. In the world of fastest fix, we look at how data packets are routed through SMS gateways. When an app like Telegram or WhatsApp requests a verification, that packet travels through a series of global servers. The theory is that if a secondary instance of the app is initialized using a specialized network bridge, it can theoretically listen for the incoming data burst associated with that specific MSISDN. That is the technical term for your phone number. This isn't about some basic app you download from the store. It's about the architecture of the telecommunications grid itself. Think about how a mirroring protocol works. It's essentially a one-to-one data map. To clone a messaging environment, the primary goal is to convince the server that the clone is actually the primary. This involves a process known as metadata spoofing. By aligning the IMEI signatures of a virtual environment to match the expected parameters of the target number, you create a digital vacuum. Now stay with me, because this next part is where most people get lost. And it's the most critical step for maintaining a permanent connection without the other person ever receiving a logged in on another device notification. If you are finding this breakdown helpful so far, do not forget to smash that like button. It helps the algorithm push this to more people who need to know the truth about mobile vulnerabilities. Let's talk about the shadow sync method. To execute this, you wouldn't look at the app interface, you would look at the API level. Most people don't realize that Signal and Telegram have open source elements that allow developers to create custom clients. By using a custom-built API wrapper, a cloning environment can be established that bypasses the standard UI triggers. You are essentially creating a parallel stream. Imagine the phone number as a key. Usually, that key opens one door. But with a network bridge, you are essentially creating a master mold of that key. When the clone environment requests the handshake, the gateway sees the phone number and validates the request based on the spoofed hardware ID. This is why you see so many people claiming they can do this in seconds. It's all about the preparation of the virtual sandbox before the number is even entered. This brings us to the zero-touch theory. In this framework, the objective is to leverage the SS7 protocol, the signaling system used by most cellular networks globally. Since SS7 is inherently flawed, messages and calls can be diverted at the carrier level. If you can intercept the signaling at the carrier level using a phone number as the routing address, the clone receives the authentication token instead of the original device. This is the fastest fix for anyone trying to understand how remote access is actually achieved by high-level researchers. However, the complexity of maintaining this without a specialized server-side script is immense. You have to consider the latency of the data packets and the heartbeat of the application's security layer. Every few seconds, these apps send out a ping to ensure the connection is legitimate. If your cloned environment doesn't respond with the correct encrypted handshake, the session is terminated instantly. This is why most simple methods you see online fail. They don't account for the cryptographic heartbeat of modern messaging apps. We are talking about end-to-end encryption protocols like the double ratchet algorithm. To successfully mirror these, your environment must be able to synchronize the encryption keys in real time, which is why having the right resources is so vital. Remember, if you're looking for those extra resources and specialized help, that pinned comment is your best friend. We've covered the network bridges, the API wrappers, and the SS7 vulnerabilities. Each of these components works together to create a theoretical clone that exists entirely in the cloud, linked only by a phone number. It is a fascinating look into the world of digital architecture and how our most secure apps are still reliant on the aging infrastructure of the global telecom grid. Make sure you've subscribed so you don't miss our next deep dive into mobile security.